So for the in-class review sheets, these are the in-class review sheets for 1, 2, and 3, exam 1, 2, and 3. And I put together all the questions that actually come in the final exam. So if you compare this with the in-class review sheet, I omitted few questions and I'll post this later. I'm still trying to find out which question they usually put in the final. So I know definitely there is one question from the first one, 3. Let me actually write them down. So every semester they give different types of questions. And here are all types of questions I seen in last few years of final exam. So if you do all of this, you'll be safe. Oh, and also this one never comes. So let me omit actually this one. And also this one is too easy. So they usually don't put these easy ones. Okay. So from the first one, there one question comes. There is always one question. Not always, most of the time. So one domain question always comes. So let me start what I always seen. This type of range question, not always, but sometimes they ask this type of question. For slope, yes, sometimes. Not sometimes means not every semester. It depends on their mood, I guess. This one comes, but not every semester. But this one every semester comes. What's the slope of the parallel line or what's the slope of the perpendicular line? And then one of these definitely come. This one mostly always come. Find the equation of the parallel or perpendicular. I have to check if it always comes or sometimes comes. This one sometimes comes. Transformation, it also sometimes comes. This type of transformation also sometimes comes. This is definitely always comes. One of these, simplify. And also this one, simplify. These always come. For multiplication, sometimes. Rationalize the denominator, mostly always. Solving radical equation, mostly always. Multiplying, so either this multiply or this multiply. One of this multiplication always come. Rationalize the denominator. Sometimes. I think sometimes. Reduce the power of I sometimes. But solving for x for quadratic, always one of these. We have 3 scenarios. One of the scenario will always come. Solving for weird quadratic. So here mostly they give 4th degree and this type of fraction. So both of these types, they always come. Solving a triangle, I always seen that. Inequality always comes. And then axis of symmetry, x and y intercept sometimes comes. Transformation, either they're going to ask you to graph it or they will give you graph and you have to find the equation. Like this. They will give you the information, you find the graph, or you to draw the graph using transformation, or the graph will be given you to find the equation. And then sometimes they ask for domain and range. So these are sometimes. Now here we have three types of questions, but I believe I seen this mostly comes one of this part. Either they're gonna ask for time or the maximum height or the
But
time. Huh?
no, we're just testing out the technology in the classroom. Like we had a camera over here. That's why, and it has a mic and it turns 360. So
Great, wonderful. You guys
see
are
it.
so smart. You could easily figure that out. Wonderful. Let me know anytime when you guys any question, any one of you, or when you don't understand my voice. I'm talking as loudly as possible, and it's actually hard to talk. So from these four scenarios, one of the scenario always come. These two I have to check whether I have seen this in the final exam or not. For composition, always. And then for one-to-one function, always there is one-to-one function. And then solving exponential, always. I mean exponential and logarithm. Huh?
This?
Yes, yes. Go ahead.
Did you post this? Yes, there's three sample finals.
This
Shit.
is the three simple final exam. So I combine them here. And then I'm going to check more final exam questions. And
Yeah,
then I'll post this one. This is just the final, the review sheet. The review sheet I posted for 1, 2, and 3. So all these questions are from the review sheets. Okay, graphing exponential equation and graphing logarithmic equation. One of the from exponential and logarithm come. So which one come? I don't know. Sometimes they give logarithm, sometimes they give exponential. But same thing here. Solving exponential or solving logarithm, one of them definitely come. Sometimes they ask question like this one. They give you the graph and you have to identify the equation. Solving these are the questions for calculator part. So one of these definitely come, or sometimes two of these. I mean, mostly always come. And then the what problems, the money problems always come. So money has many different scenarios. For example, here you are looking for how much you have to invest today, means P. Here in the next one, you're looking for how how long it will take, means T. How much money you'll get in the future, so A. And then you're finding the interest rate, which is R. So one of these scenario will always come. Which one? I don't know. And nowadays they start giving one of these or sometimes both of them. Where you're going to use exponential to find life of some bacteria or something like that. Now for transformation, either log or exponential, okay? One of these transformation. For example, they ask you this type of question. They give you the graph and you can identify its equation. Expanding log always come. Writing as a single log sometimes comes. Solving log. So between log and exponential, one of them definitely will see. The what do you call change of base formula? definitely counts. And then solving ln, this is definitely, you'll see in the exam. And then from 13, the circle always come. And then tangent line sometimes come. The distance sometimes come. And one of these sometimes come. Mostly it comes one of these, but some semester they skip it. And that's our entire syllabus we went over. So let me see how many I started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. So the entire review sheet is actually a collection of final exam. So I'll suggest please do these questions. They don't have any solution because most of them we did in class. And nowadays you don't even need the solution. You can just put it on AI and then they'll give you the answer. And I'm not telling you to use AI to look at the solution. I'm asking you if you need to know whether you did it correctly or not, then you can match your work with AI's work or do a group work, study in a group, and then you'll see someone in your group will have correct answer. And if you want me to check, you can do all of them and then send it to me. And then, I mean, it will be too much for me. No, never mind. If you question on any question, then I can go over that with you. If you need help, you need my help. But what is my plan for today is going over the most recent final exam from here. What question I have seen in the most recent final exam. So any question before we start? No question from anyone? Okay then. So let me go over one by one. I'm going to go over 30 questions. That's my plan, going over 30 questions today. So from here, I'm going to go over the domain questions. I need the domain, so let me go see. We have 1 equals x over 28 minus 7x squared. Domain means what number we can plug in our formula, in our equation, and we get valid number, valid y value. So domain means which x values are allowed. So how do we find them? First, we identify the problem. For domain, for rational, there is a problem. Our problem is a denominator. Denominator cannot be negative. So denominator cannot be 0. Denominator cannot be 0. So first identify your problem and then start from your problem. Either your problem or condition or whatever. Here our problem or condition is denominator cannot be 0. So what do we have on the denominator? 28 minus 7x squared. So this denominator cannot be 0. And now we are going to solve for x to see which x value makes the denominator 0. So we can add 7x squared to both sides, or you can subtract 28. It doesn't matter. We get 7x squared on one side, cannot be equals 28. And then to solve for x, we need to get rid of the 7. So we get x squared cannot be 4. Now, what number when you square, you get 4? So you take the square root and you see x cannot be two numbers. One is positive 2 and one is negative 2. That means from the number line, negative infinity to positive infinity, you can plug in any number, but you cannot plug in two numbers. One of them is negative 2 that you cannot plug in, and one of them is positive 2 that we cannot plug in. Besides these two, you can plug everything before negative 2, between negative and positive 2, and bigger than positive 2. You can plug in the entire number line. Just don't plug in these two numbers. But you have to write them in interval notation. So you write each of these interval into interval notation. The first interval is the lowest number negative infinity and the highest number negative 2. You put them together in a parenthesis. It has to be parenthesis because parenthesis means we cannot use the number next to the parenthesis. And we cannot use negative 2. Now in the second interval, the highest number is negative 2 and the lowest number here is positive 2. So you put them together in one parenthesis. And then you go to the last one. The last one, the highest number is 2 and the smallest number is 2 and the biggest number is infinity. So you put them together in a parenthesis. So this is the domain in interval notation, which says plug in any number for your x, just don't plug in negative 2 and positive 2. So this is the scenario when you have the denominator problem. Let me also do the other problem, which sometimes comes. The second problem is radical issue. So if y equals to square root of 100 minus x squared. Now for this type of question, our condition or the problem is that we can have only positive radical or zero radical. We cannot have negative radical. Negative square root doesn't exist. So our radical has to be either positive or equals to 0. One of them is the condition. Like they can be positive or they can be 0, but they cannot be negative. So what do we have in our radical? We have this thing. So you can start with by 100 minus x squared. This can be positive, means bigger than 0, or can be equals to 0. So this is our equal sign. And then you solve for x. To solve for x, you can square both sides. So you get 100 minus x squared is bigger than 0. And then you can add x squared. So we get 100 bigger than or equals x squared. And then we do something weird. We look at a class table. This looks weird because we always have x term on the left, yet our x term is on the right. So we can flip this entire inequality. So we can put x squared here, we can put 100 here, and if you observe, the mouth of the inequality is toward 100, so we have to keep our mouth same. Cannot change the mouth. So our mouth is toward 100, we keep our mouth is toward 100. And then if you try to take the square root, it doesn't make sense because you're looking for all the numbers that is smaller than 100 when you square them. So you have two choices. Either use the number line to figure that out, or you can do actually one by one. For example, 0 square is 0, it's smaller than 100. Smaller than or equal. 1 square is 1, it's smaller than or equals to 100. 2 square is 4, it's smaller than 100. 3 square is 9, smaller than 100. 4 square is 16, smaller than 100. So you can find one by one each one of them, or you can simply solve for x. If you solve for x, then you shouldn't use the inequality anymore. You should use just the equal sign. When you use only the equal sign, then you can take the square root and you see x is plus 10 or minus 10. That means every number from negative 10 to positive 10, all of these, if you take the square, so negative 10 square is 100, positive 10 square is also 100. And if you take anything between, let's say 5 square is 25, less than 100. So all these numbers from here to here are less than or equal to 100. That means your domain is from negative infinity to positive infinity. And this time we are going to use bracket because negative 10 is 100 and you're looking for something that is equals to 100 or less than 100. So negative 10 square is 100. So we're allowed to take it. Positive 10 square is also 100. So we're allowed to take it. So whatever, in other words, if you have an equal sign in your inequality, then your answer is supposed to have bracket if you don't have a denominator. So you can use logic to find out, or you can simply use the number line to test it. Which of these interval gives you all the numbers that is either equals to 100 or less than 100. So these are the two scenarios. One of them definitely you're going to see in the final exam. Any questions so far? No question. So I'm going to do this. I'm going to do one part of the review with you and then the next part of the review with my afternoon class. So please watch both recording so you can have enough time to complete the reviews. And I'm going to send out an email about the location of the final exam. Our final exam will be next week, Tuesday. Wow. Unbelievable. Only 1 week. So our final exam is next week, Tuesday, 8 a.m. in the morning. Not in our regular classroom. It will be a different classroom. So keep an eye on Brightspace. I'm going to post an announcement and send you an email about the location. Okay, the next question is a graph of discontinuous function and you have to find domain and range. So domain, we already know the x values. So what x values you see in your graph? So we have first part here. In this part, we have the x value -2 until x value +1. And then we have second part here. In this part, we see x value +1 and then x value +3. So if you observe the entire collection of the x values, you see it's from -2 to +3. And even that one they broke down and we have a hole here, but we have a closed circle here. So there is a y value for x equals to 1. It's not here, but it's there on the bottom. So we don't have any gap in the y values. Since we don't have any gap on the y values, that means we use this x value and we have a valid y value for that. So the entire, if we the combine the entire interval from -2 to +3, they all have some valid y values. But when you are at 3, there isn't any valid y value because it's a whole. That means we did not use 3. If you did not use a number, if you do not use a number, then it's a parenthesis. Or other words, if you have a whole, it's a parenthesis. So whole means parenthesis, and if you have a closed circle, means bracket. So anytime you see a whole for any number, you're supposed to use parenthesis for that number. So -2 doesn't have a whole, it has a closed circle. So that's why -2 will have a bracket. But 3 has a whole. Let me actually list this so you can see. 3 has a whole, so 3 has to get parentheses. Now for range is the y value. What y values you see in your graph. So for this portion, the y value starts from 3 and ends at 5. So this is the y value we have for the top portion. For the bottom portion, this is the y value we have, and this is the next y value we have. So for this portion, the y values we use are these two. So these purple lines are the only numbers we see in our graph as y values. So that's our range. Anytime we write any type of interval, we have to write small to bigger. So our smallest number is -4 and our biggest number is -3 on the second part. Now for this one, we have a whole, so we have a parenthesis at -3. But for this number, we have a closed circle, so it's going to have a bracket here. And as you can see, these two intervals, they are not connected. They are two separate intervals. So we cannot combine them like x. We have to separate them because they are not same. They're not continuous. They are separate intervals. And then on the upper part, we have 3. And for 3, we have a closed circle. So 3 gets bracket until we have 5. But when we have 5, it's an open circle. So at 5, we are going to have a parenthesis. And this is our range. The range has 2 parts and domain has only 1 part.
I have a question.
Go ahead.
How many questions are going to be on the final?
32.
30 questions.
Are they all multiple choice?
No, total 30 questions, 2 hours. In these 30 questions, there will be 8 questions in the calculator part and 22 questions in non-calculator part.
You'll be there to administer the test, or will it be somebody else?
I will be there, and then some people from the department will come and check.
Proctors? Yeah.
Yeah, I will be there all the time, and then the department person, they will come twice.
Oh wait, Miss,
Yeah,
come to school on Thursday.
we have a
Do I
class on Thursday.
Sign up form before the end of the week or else something.
No, we have a class today and Thursday. This week is the last week for us. And if you have a Monday class, then next week, Monday is the last day of class. And our final exam will be Tuesday.
What?
Yeah. Our final exam will be exactly 1 week from today. Next week, Tuesday.
Ask her the time.
What time is it, miss?
8 a.m. in the morning.
Can't make it at 10.
Is that when it starts or when we have to be there?
8 a.m.
Wait,
it will
miss,
start,
that's
and it will-
different from the email I got.
No, the email you misunderstood. Because it's always 8 a.m. to 10 a.m. And
Oh,
if
wait,
you're
never mind. Okay, yeah, never mind. That's right.
if you are 20 minutes late, then you cannot take the final.
What? Miss, I'm pulling it all-nighter.
No, it's not my rule, it's the departmental rule because the exam is too long. So if you already miss 20 minutes, that means you cannot finish the final. So you're going to fail the final. That's why
Holy
they don't like
shit.
you. Uh-huh.
That means I gotta wake up early.
That means you cannot sleep the night before the exam.
Yep, correct.
Exactly. So you can do this actually. You can go to school Monday and then sleep in the school, in the classroom. Some students,
No!
some students actually did that before. They live far away, so they just stayed in the classroom. And
Oh.
then the next morning, when I opened the door, they were like sleeping. I was like, "What are you guys doing here?" And they're like, "Well, we slept here last night."
Oh
I
my
was like,
God, they
wow.
slept in the classroon?
Yeah, because they
Holy,
wouldn't be able to come early,
holy
8 a.m. in
crap.
the morning.
Wait, can I do that?
Yeah, you can do that.
Really? I can sleep in your classroom?
Sure, but
What? Yo,
don't tell
Girk, we on
others.
a sleepover?
Don't tell others because I don't know it's legal or not. I just
Oh.
opened the door.
Does
I
it
opened
matter?
the door and found them sleeping in the classroom.
Oh.
I don't think them getting arrested. The lab is actually.
All of all except Brim.
So if you know you definitely cannot wake up early in the morning, I'd suggest a sleepover. That's the best choice you have. Okay, anyway, so I don't know if it's legal or not, okay?
Okay.
I just saw them sleeping
Okay.
in the classroom.
Got it.
So there will be one domain questions from equation, and there will be one domain question. There might be one domain question about from the graph. And then this definitely will be in the final. Find the slope of the parallel or perpendicular line. One of them, either parallel or perpendicular. Usually they like perpendicular because it's opposite. So to find the slope of the parallel and perpendicular line, all you have to do is solve for y, and that will tell you what do you need. So solve for y. So we have 7x plus 6y equals 11. Either you solve for y or you just remember one formula. Not formula, remember one thing. The slope is actually x coefficient divided by y coefficient. That's your slope. Oh, negative x coefficient over y coefficient. So if you can remember this, your life is easy. You don't have to do any math. All you have to do is look at the x coefficient. Our x coefficient is 7. Our y coefficient is 6. And then you change the sign. So this is the slope of the parallel line. Parallel line have the same slope as the original line. So they give you a line, and so it's negative. They give you a line and they want you to find parallel slope of its parallel line or slope of its perpendicular line. So parallel lines, they have same slope. So if you can find the slope of the original line, this is the slope of the parallel line. Oh, what I'm doing. This is not parallel symbol. This is parallel symbol. Two lines are parallel, so we indicate that with double layer and double line. And perpendicular line is the negative reciprocal. Means you have to change the sign. So the negative sign turns into positive sign, and then you flip your fraction. So you get 6/7. This is the perpendicular slope. So if you can remember the slope of the original line, you don't need to show any work. You just tell me this equation and then I'll give you points. But if you cannot remember, that means you have to solve for y. So to solve for y, you need to subtract 7x from both sides. So you get 6y equals negative 7x plus 11. And then to get the y alone, lastly, you divide by 6. And whatever we have here, that's your slope. let me do B also using shortcut. So our slope of the normal line, the regular line, is negative of the x minus the y. The negative of the x minus y. So here we have -5 and then -8. Negative cancel out. We get 5/8. So this is the slope of the parallel line. The same slope. But the perpendicular line has the negative reciprocal slope. Means you are going to change the sign and you're going to flip the fraction. So fraction will be -8/5. The two choices, either solve for x, so you solve for y, or use this thingy. And then one of the scenario you'll see in the final. Sometimes they ask for parallel, sometimes they ask for perpendicular, sometimes they ask for the x-axis, sometimes they work with the y-axis. So it's a combination of these. Which one you will see, I don't know. So let me go over all four. The first one says, find the slope of the line parallel to the x-axis. So all you have to do is draw your x-axis and draw a parallel line. Come on. Let me save it. And I have to restart. Okay. So it says the line parallel to the x-axis. So draw your x-axis and then draw a line that is parallel to that. So any line either here or there, these are parallel line. And then they're asking for the slope. So these lines all are horizontal line. Horizontal line. Do you know what type of slope horizontal line have? Do you remember? What's the slope for any horizontal line?
Oh, y equals
Y equals 0. So not y equals 0, m equals 0. The slope is 0. So any horizontal line has slope 0. So that's all you have to do. Draw your x-axis and draw some horizontal line, and you can see your answer is 0. The slope is 0. If you have a vertical line, what's the slope of any vertical line? I didn't hear you.
undefined.
Undefined. So any vertical line has undefined slope. Any horizontal line has 0 slope. So you just have to visualize what is given to you. They are asking for slope of the line parallel to the x-axis. So x-axis is a horizontal line. Its parallel line will be also horizontal. The slope will be 0. In the next one, they're asking find the slope of the line perpendicular to the x-axis. So you're going to draw your x-axis and then draw a perpendicular line. So perpendicular line, they intersect with a 90 degree. That means the line we have here is a vertical line. So slope of any vertical line is undefined. So you're just going to write the slope is undefined. You don't need any math. You just draw x-axis or y-axis and they are parallel or the perpendicular line. So this is A, this is B. Now for C, it's asking for slope of the line parallel to the y-axis. So you're going to draw your y-axis. This is y-axis. If you draw a line that is parallel to the y-axis, you have to draw another vertical line. And slope of any vertical line is undefined. So the answer for C is just undefined. You don't need any math. And lastly, for D, it's asking for slope of the line perpendicular to the y-axis. So if this is your y-axis, its perpendicular line has to be a 90-degree angle. So this has to be a horizontal line, and slope of any horizontal line is 0. Any question? No question from anyone? Yeah. Yeah. Oh, okay. Let me know, okay? Anytime you have a question, just stop me. And anytime you don't hear me or don't understand me, stop me, please. Okay, the next line is asking for equation of the line that goes through a point with some slope. So they gave us M, they gave us X1, and they gave us Y1. So you're going to start with the equation Y minus Y1 equals slope times X minus X1. And usually they like the equation in standard form. So you have to bring X and Y on one side and the constant to the other side. So first we are going to substitute. We have Y minus or Y1 is 6. Our slope is negative 1/2. And our X1 is negative 5. So we get double negative here, which turns into positive. So y minus 6 equals negative 1/2 of x plus 5. And since we need to bring x and y next to one another, that means you have to distribute. And you also, distribute is fine. Just distribute first. So we have y minus 6 equals negative 1/2 x minus 1/2 of 5. And then since we don't like the denominators, so if you want, you can get rid of the denominator now. To get rid of the denominator, you're going to multiply the entire equation by the denominators. So denominator is 2, so you're going to multiply the entire one by 2. So what do you get? You get 2y minus 2 times 6, and then 2 times negative 1/2 of x minus 2 times 1/2 of 5. So these two cancel out. There is no more denominator. This is 5. So we get 2y minus 12. And here we get negative x. And here we get negative 1 times 5, which is 5. Now we just need to bring x and y together. And we don't need this 12. So we are going to add x and add 12. So 12 will get banished from the left and x will get banished from the right. As a result, we are going to have x plus 2y. This 2y has an invisible plus sign here. So x plus 2y and minus 5 plus 12. 12 is bigger, so we are subtracting 5. We get 7. So first you replace, and then you can get rid of the denominator, and then bring x and y next to one another. So these are the steps for finding the equation. And then these sometimes come, so let me skip all of these and do one of these. It's a simplify 8 to the power negative 2/3. Do any of you remember how do we simplify?
Yeah, you convert it to like 2 to the power. So it should be 2 to the power 3 to the power. Or never mind, you can just turn it into a fraction, right? Or square root. Oh, cube root, cube root.
Yes, we are going to turn this to a fraction with the power, but we are going to do that later, not now. Or never mind. I mean, it's up to you. You can do the fraction fast and then simplify, or you can simplify fast and then fraction.
Right, so it would be 1 over 2 over 3, right? Oh, 8 to
1 over 8 to the power 2/3.
right.
So
And
fast. And then what do you do?
you put it you rewrite this as cube root of 8 squared. Or is it the other way around? I think that's it. Cube times 2
Cube.
2 cube. Oh yeah.
You rewrite 8 as a 2 cube, and you have 2 over 3.
Right.
So 2 cube. And why did we rewrite? What is our goal? So what can we do?
You just multiply 3 and the 2/3, right?
So when you multiply this 3 and this denominator 3, they cancel out. And that was our goal, to cancel out the denominator, because we hate denominator. So when you cancel out the denominator, we get 1 and then 2 inside, and we have this 2 power outside. So we get 1 over 2 square, which is 1/4. And that's how we solve all of this problem. We need to, if you have a negative power, then you're going to turn them into fraction, step 1. And step 2, you're going to rewrite all the bases in terms of the denominator. So let me do one more with some positive power.
Well, big number.
Big one. Which big one you want me to do?
Either E or F.
E or F, okay. Let's do E. So 243 to the power negative 4/5. Now you see the power 5th on the denominator. That means this 243 will be something to the 5 power. So step 1, turn into fraction. 1 over 243 to the positive 4/5. And then we are going to rewrite this 243. So when you see big number on the denominator, you start from 2. Let's see what is 2 to the 5. So you multiply 2 times 2 times 2 times 2. And you get 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So the denominator is not 2 to the 5. So you start with 3 to the 5 then. So multiply 3, 3, 3, 3, 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3. 3 times 1 is 3. 3 times 8 is 24. So yep, we get 243 if you multiply 3 5 times. So this becomes 1 over 3 to the 5 inside and 4 over 5 outside. We rewrote because our goal is to cancel the denominator with this power. So you get 1 over 3 on the base and this 4 on the power. So it means you're multiplying 3 4 times. 3 times 3, 3 times 3. So you get 1 over 81. So usually in this class, it will be smaller number from 2 to 5. If you have a big number, the answer is definitely either 2 or 3 or 4 or 5. And for smaller number, it's up to, I will say, 10. And let me do one with no denominator. Sorry, with no fraction. Not fraction, sorry. No negative sign. Like A. We have 16, 3 to the 4. since this one doesn't have any negative power, so it will not turn into fraction. So not fraction. So what we are going to do, we are going to just rewrite this 16. So we keep our 3/4 power and 16. We are looking for one number to the which power? How do we rewrite 16? What power we are looking for, guys?
4 to the 4. 2 to the 4.
What
Four.
power? So what number when you multiply 4 times turn into 16? Which number when you multiply 4 times then say 16? 2. Great. So you rewrite this 16 as 2 to the 4. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So when you multiply 2 4 times, the result is 16. So when you rewrite, our goal is to cancel the denominator because we hate denominator. So we left with 2 inside and the 3 power here outside. So it becomes 2 cubed. Means 2 times 2 times 2 and we get 8, which is not a fraction. It's not a fraction because our power is positive. The other 2 was fraction because our power was negative. Yes, Eliza, I'm going to post this on YouTube.
Miss,
Yeah, Terence.
is it okay if I leave a little early so I can get to school?
Okay, but make sure you watch the recording.
Okay, I'll watch the recording. Thank you, Miss.
Okay, now this is another question they most of the time put in the final exam. Okay, Shahida, no problem. Okay, so this one we have 6 x to the negative 3 to the power negative 2 and 2x to the negative 2 power to the power 2. So this is the rule for all the exponent rules. It's a combination of all the exponent rules. So first step, we have some outside powers. So we are going to distribute that into our base. So numerator is negative 2, we are going to distribute on the numerator. Denominator is positive 2, so we are going to distribute on the denominator. So we get 6 x to the negative 3, 2 x to the negative 2. All of them get their individual power when you distribute. Numerator has negative 2, denominator has positive 2 power. And then we use the power rule when you have 2 powers together. So when you have 2 powers together, every negative power do not change anything. Keep the negative powers and the positive powers. If you want, you can apply that. So 2 squared is 4, we know we can apply this. But 6 to the negative 2, do not touch that because they have a negative power. Negative powers are dangerous. So do not touch negative powers. And then we have x on the top, x on the bottom. Now what powers we have from here? Do we multiply them or do we add them? What's the power rule for this type of exponents? Do you guys remember? If you have x to the m and then m, what do you do? Do you multiply the powers or do you add the powers or do you subtract the powers? Do any of you remember? multiply. Yep. So we have m times n. Same thing here, we have -3 times -2. So it turns into +6. And on the denominator, we have -2 times +2. So we get -4.
So we flip it, right?
Mm-hmm. So for negative powers, we have to change their position. For positive powers, they stay on their position. So when you're positive, nothing can move you. So you stay on your position. But when you're negative, people can move you easily. That's why this negative will come down to make it positive. This negative will go up to make it positive. So there will be two things, they will change their position. This thing from the numerator and this thing from the denominator. Their position needs to be changed. So we have 4, it states. We have x to the 6, it states. These two do not change the position. But 6 to the -2 goes on the denominator and turn into 6 to the +2. And x to the -4 goes on the numerator and turns into x to the +4. So the negative powers change their position. For positive powers, keep them. Do not change the position. And then we apply the power rule again. When we have multiplication in the base, how do you combine the power? Do you add them, subtract them, multiply them, divide them?
Add
Add them. So we get 4 plus 6, 10. And on the denominator, we have 4 times 36. So you're going to multiply them manually. 4 times 36. 144. Okay, I'm trusting you. 144 on the denominator, x to the 10 on the numerator. So that's how you simplify all of these. Step 1, distribute the power. Step 2, use the power rule to multiply them. Step 3, for any negative power, switch their position. And finally, step 4, again, use the power rule to combine them or multiply the numbers. Any question? Okay, then. So so we have multiplying and dividing radical. So sometimes they put multiplying radical, sometimes they put dividing radical, but one of them definitely will come. And from the multiplication, usually there is always one, either from radical multiplication or multiplication with I, the imaginary number multiplication. One of the multiplication you'll definitely see. Let me go over the division once, and then probably with my other class I'll go over the multiplication one. It says rationalize the denominator. Means you don't want the radical on the denominator. So we have 9 divided by 6 plus radical 3. Do any of you remember how do we get rid of this radical? This is rationalizing, means get rid of the radical. So what can you do so that you can get rid of this radical? Do any of you remember what do you do? No.
Find the conjugate of the denominator. To both the denominator and the numerator.
Yeah. Conjugate. So conjugate means the same sign, the same two terms, but their middle sign is different. So you multiply numerator and denominator by the conjugate. So when you multiply to conjugate, either you can use FOIL to multiply them, or you can simply use the difference of perfect squares. when you multiply x plus y and x minus y, the answer is x squared minus y squared. So anytime you multiply to conjugate, the result is the first term squared minus the second term squared. These are my square here. So that's why we use conjugate, because you don't have to use FOIL to get rid of the denominator. And for numerator, keep it, since it's only one term, so let's keep for now and see what can we do later. So we get 9 times 6 minus square root of 3. And then we have 6 squared, 36. For radical 3 squared, the radical and square cancel out. We get minus 3. So 36 minus 3 is 33. And we get 9 on the top. 6 minus square root of 3. So you're done with rationalizing. But as you can see, both of these numbers are divisible by 3. So you reduce them by 3. 3 goes to 9 3 times. 3 goes to 33 11 times. So we get 3 times 6 minus radical 3 divided by 11. If you want, you can distribute the numerator. It actually depends on the multiple choice. If you see on the multiple choice they distributed the numerator, then you distribute. Otherwise, you can just keep it. Since Eliza is asking for multiplication, so let me do one multiplication. So there are two types of multiplication, either this type or the rest type. One of these multiplication, usually they put in the exam. But some semester they don't. So let me go over both types. Let me go over B first. So we have cube root of 3x to the 7 times cube root of 18x to the 9. So to simplify this, step 1 is separate them with their own rule. So we have 3 times 18. So these are the numbers. We put them together under one radical. And then our variable is these two. So x to the 7 times x to the 9 goes under another radical. And then do not try to multiply 3 times 18. Because if you do, you get a big number and then you get stuck. So instead of multiplying, you just need to split them, because our goal is to have the same number 3 times. You have to see, can you find one number 3 times inside these 3 times 18? So 3 is 1 times 3 and 18 is 9 times 2. Now 1 we cannot reduce anymore, 3 we cannot reduce anymore, 2 we cannot reduce anymore. So these 3 numbers we cannot reduce anymore. However, the 9 is more reducible. It's 3 times 3. And now we cannot reduce them anymore. So 3 times 18 is 1 times 3 times 3 times 3 and then times 2. So we can see this 3 times 18 has 3 times. So we put 3 times and then 1 and 2 together. 2 times 1 is 2. Okay, Krish, no problem. They're having a good time in class, Krish. They're missing you. Exactly. Why is Cairo? He's not in class. So he's missing a very important there. Wow. Okay, so we have 3 cube and 2. So we put them separately under the cube root. Cube root of 3 cube and cube root of 2. The cube root and cube power cancel out. So we get a free number 3. And this one we cannot reduce. So it stays same as cube root of 2. So we simplified our number. Now we go to the variable. We know in multiplication we add the powers. So we get x to the 16. Now for 16, we can split into 2 pieces. One is x to the 15 and one is x. Why it's 15? Because 15 is divisible by 3. So cube root of this and cube root of that. This one turns into x to the 15 over 3, which is 5. And this one is not reducible, so we keep cube root of x. Cannot reduce that. So from here, we get x to the 5 and then cube root of x. Now, if you observe, this 3 is free. It doesn't have any problem. This x to the 5 is free. It doesn't have any problem. So we put them together. 3x to the 5. And then this 2 is inside the radical. This x is inside the radical. So we put them together inside the radical. 2x inside 1 cubic root. And this is our final answer. You reduce the variable and then you reduce the number, you reduce them individually, and then the results, the final result, you put them together. The free things goes outside the radical. The baby things that are not free goes back inside the radical. So this is one type of multiplication usually they ask for. Another type of multiplication is the other two. So 4 root 2, 3 root 2. Let me do one of them. 4 root 2, 3 root 2, and then what? Plus 7 minus 4. Plus 7 minus 4. So in this multiplication, all you have to do is FOIL them out and then simplify. So first you multiply this. You have 4 times 3, 12, and then root 2 times root 2, which is root 2 square. Then you multiply the next terms. So you have minus 4 times 4, 16, and then radical 2. Then you go other way around. 7 times this is plus 7 times 3 is 21, and then root 2. And lastly, 7 and negative 4 is negative 28. So use FOIL to multiply and then you simplify. The radical and the power cancel out. So you get 12 times 2, which is 24. In the middle, you have like terms because they both have square root of 2. So you keep your square root of 2 and then you combine their coefficients. We have negative 16, positive 21. So answer is positive 5. 28 minus 16 is 5. So we get them from here. And then lastly, we bring down our negative 28. And now we have these two like terms. 24 minus 28. So we get 5 root 2. 20 is bigger with a negative sign. So answer will be 4 with a negative sign. It's 5 root 2 minus 4. And this is the answer. When you do conjugates, you can still do FOIL, but for conjugates, your answer is easy. You just square each quantity, each base, and you subtract them. For example, these two are conjugates. So if you want to FOIL, you can FOIL, but you don't have to FOIL. All you can do is square this quantity and square that quantity. So we get 5 squared square root of 19 squared minus 1 square. So we get 25 minus 19 minus 1. Then you multiply 25 and 19 and you subtract 1, and that's your answer. So this is one of the easiest way to multiply them because they are conjugates. Usually the same two things. There are 3 types of multiplication. This one, or the conjugates. So either they put this type of multiplication or they put multiplication with the I, one of them. But definitely one of this multiplication. And then radical equation. When you do radical equation, don't forget to check your work. Or in your last exam, when you solve logarithmic equation, the answer you found was x equals -9 and x equals -3. Most of you did not check your answer and you said these are your solution. If you said these are your solution, you got 0 because it's wrong. You must substitute them into the equation. So there are few types of equation you must check your work on. One of them is radical, one of them is log, and one of them is rational. These are the 3 types of equations you must check your answer. So same thing in the radical, whatever you get, you have to substitute into the radical equation, not the part without radical. You need to use the radical because radical gives us the problem. We don't want the radical to be negative. So if any answer makes the radical negative, then it doesn't exist. So let me do B from here. It says 3x plus 1 under the radical minus x equals -1.
Miss, I got a question.
Go ahead, Omar.
We can use ChatGPT for the final or no?
You mean
Huh?
during the final exam?
Yes.
To study for the final or during the final exam? During the final exam? Come on,
During the-
Omar. What type of question you're asking me? How can you be allowed to use ChatGPT or any type of technology in the exam? Of
I'm
course
sorry.
not. You can use it to study as a tutor, but during the exam as a helper, no.
Jack just told me to ask for him. I did not say that.
No, thank you. You're not allowed to use any type of technology. You cannot even use your neighbors. So
Damn.
exam is totally your brain. You have to show me your brain, not ChatGPT's brain or your neighbor's brain. And in the final, there will be actually 2 of my classes together. So there will be a mismatch. You may not be able to sit next to your friend. Okay? So don't rely on your friends. Study on your own. I mean, study together, but make sure be independent. So, for radical equation, our goal is to get the radical alone on side.
No, one more question, Liz.
Go ahead.
Calculators will be provided or we gotta get our own?
You have to bring your own calculator.
Thanks for that. Alright.
Just like the last exam. Bring your own scientific calculator. And Terence, or Terence he left probably. There is no graphing calculator. It will be only scientific calculator. Any other question?
No.
Okay then. To solve radical equation, do you remember we talked about bodyguard? When radical has anything in the front or anything on the side, they act as a bodyguard. So radical is very strong around bodyguard. So that's why first you have to kill all the bodyguards so that the radical is alone. So we add x to both sides and we kill this bodyguard. And we get our radical term alone on one side. And on the other side we get x minus 1. And when your radical is alone, it becomes very weak. So we invite the square to kill the radical. So radical get vanished and we get 3x plus 1. And on the other side, it's not distribution, it's foiling. X minus 1 times x minus 1. So you have to FOIL them out and you get x squared minus 2x plus 1. Anytime you see more than one x terms, you should bring everything to one side. So you subtract 3x and you subtract 1. So you get big 0 on one side and you get x squared minus 5x on the other side. A plus 1 minus 1 cancel out. So we have two terms. When you have two terms, there are only two things you can do. One, either you can pull out a GCF, means a common term, you can pull out a common term, or there might be difference of perfect squares. So one of these two choices will always be the case. You have to identify which one is the case and you're going to apply that scenario. So in our case, you have x squared minus 5x. What do you see? Is this a difference of perfect square or you can pull out a GCF? Which one? What do you observe here? Do you see a common factor or it's a difference of perfect squares? Do you see anything, guys?
Take out the x and then just put x and then parentheses x minus 5.
Yeah. So it's the GCF, means a common factor. They both have x in common, so you get x minus 5.
Yeah.
So it's not it's not two binomial. It's one binomial and one monomial.
Equals 0, x equals positive 5.
So you set x equals 0 and it's already solved, so you have nothing to do. And you take x minus 5 equals 0 minus 5, right? X minus 5, 0. And you get x equals 5. Give me 1 second, my mouth is too dry.
I heard about it. The what? 50 Cent Diddy documentary. I'm trying to watch it. Jesus watched that already.
Huh?
Yeah. Why are you?
And then you have to check your work. And when you check your work, you have to use the original equation. You cannot use the original without radical. You must need the radical to check. So you check both sides. If you get the same thing on both sides, then you accept the answer. If you don't get the same thing, you don't accept. So first, x is 0. We get 2 times 0 minus 1 under the radical plus 7 equals 2 times 0. So we get 0 minus 1. So we get negative 1 plus 7 equals 0. And this negative 1 is automatically undefined. It doesn't exist. So you cannot accept x equals 0 as your solution because it's not real. Then you check x equals 5. 2 times 5 minus 1 plus 7 equals 2 times 5. Now 2 times 5 is 10 minus 1. So it's 9. Square root of 9 is 3. So you get 3 plus 7. And on the other side you get 10.
Professor?
Yeah.
Ronald said you're doing the wrong equation. You're checking A instead of B.
Thank you. Yeah. Oh my God. What's wrong with me? Thank you for catching that, guys.
I think it's more detailed about it, but
The equation is 3x plus 1 minus x equals negative 1. So it's 3 times 0 plus 1 minus 0 is negative 1. And 3 times 5 plus 1 under the radical minus 5 equals negative 1. So we get 0 plus 1, which is 1 under the radical. So we get 1. 1 minus 0 is 1, but on the other side we have negative 1. 1 and negative 1 are not same. So you still don't accept x equals 0. Because the left side of the equation doesn't give the same number as the right side of the equation. So you check 5. 3 times 5 is 15 plus 1, so you get square root of 16, which is 4. And we subtract 5. 4 minus 5 is negative 1. And on the right side, we do have negative 1. So we have the same number on both sides of the equal sign. So we accept x equals 5 as our solution. So final exam is multiple choice. Okay, I know. So they will give you the choices. A, x equals 0. B, x equals 5. C, x equals 0 and 5. D doesn't exist or no solution. Okay, so maybe another one, x equals 0 and negative 5. So they'll give you all sorts of choices and you must check, otherwise you may think this is the correct answer, which is wrong. X equals 0 and 5 is not correct answer. X equals 5 is the only correct answer. So you have to check every radical equation, every logarithmic equation, and every equation with the denominator. Okay. Any question? Then we have a multiplication with the I. It's same as what we did with the radical. You just have to use FOIL for this. And since these are conjugates, so you can use perfect squares. So if you do for foiling, you do 9 times 6, 54. And then 9 times negative 7i. 9 times 7 is 63 with the I. And then you do 2i times 6, which is positive 12i. And then 2i times 7i. So 2 times 7, negative 7 is 14. I times I is I square.
Professor, question.
Go ahead.
Since you're not, I don't think you're gonna be able to finish the whole thing in one setting. Are you gonna post the rest of it? To the
Yeah.
other?
The rest I'm going to go over with my second class, and I'm going to post the recording for both class on YouTube.
Thank you.
And then in our next class, we are going to do another review, another final exam.
All right, thank you.
So do you guys remember what is I square? Do any of you remember what is I square?
Negative, I think. Is it negative? Yes.
Negative 1. Every I square becomes real number. It's a negative 1 real number. So this negative 14 times negative 1 turns into positive 14. And we have positive 54. And in the middle, these are like terms. So when you combine them, you get negative 3 minus 2 is 1. 6 minus 1 is 5. So you get 51i in the middle. And then we see these two are like terms, so we combine them. 54 plus 14, we get 68. And we have 51i. So real number should be written first, and then the imaginary number. So when you do FOIL, this is what you do. And when you work with conjugate, you see the same 4 and same 2i, only their signs are different. So all you have to do is take 4, square this, subtract, take 2, square this, take I, square this. So you square all the bases, and then you simplify. 4 square gives us 16, 2 square gives us 4, I square gives us negative 1. So we have 16 plus 4, and then this becomes 20. You can use FOIL, but you don't have to waste. You shouldn't use FOIL because in the final exam you don't have enough time to waste. So you should do as many valid shortcut as possible. Now one of these division also counts. Sometimes they give you 1 digit on the denominator. Sometimes they give you 2 terms on the denominator. So let me go over both. On the top we have 5 minus I. On the denominator we have negative 2 minus 3i. So just like radical, in order to get rid of the I from the denominator, we need to use conjugate. So we are going to use the same 2 terms, negative 2 and 3i, negative 2 and 3i, negative 2 and 3i. Only their middle sign will be different. You are given the minus sign, so you are going to multiply with the plus sign. In conjugate, there is only one sign change. You cannot turn negative 2 into positive 2. No, the negative 2 stays as negative 2, and you're going to change the middle sign between the two terms. As a result, we get negative 2 squared minus 3 squared and I squared. So we get 4 minus, this is negative 1. So negative 9 times negative 1 turns into positive 9. Basically, we get 13. Now you're happy because denominator doesn't have any radical. On the numerator, you are going to do multiplication. 5 times negative 2 is negative 10. 5 times 3i is 15i. Negative I times negative 2 is positive 2i. And then negative I times 3i is negative 3i squared. every I square means -1. So this -3 turns into +3 because of the I square. In the middle, these are the like terms. +15i plus 2i, that gives us +17i. And then we have -10. Now -10 plus 3 are like terms, so you get -7 and then 17i. But the complex number, they have to be written separately. So you separate the numerator by keeping the denominator. So -7/13, and then we have in the middle the plus sign, and then we have 17i/13. That's how we rationalize the denominator with imaginary number. Now for when you have one term, life is actually much easier. For example B, we have 7 minus 5i on the numerator and only 4i on the denominator. Now the denominator has only one problem, this I. 4 doesn't have any problem because 4 is real. I is the only problem because I is not real. So we multiply the numerator and denominator by the problem, I. Do not multiply by 4i. Multiply by only I, because 4 doesn't have a problem. So we get 4i squared, and now this I squared turns into real -1, so we get -4 on the denominator. On the numerator, distribute, so we get 7i minus 5i squared. Because of the I squared, this negative turns into +5. And we get 7i. But when you write complex numbers, you have to write the real number first and then the imaginary number. And then you have to separate the denominator. In other words, we get 5/-4 minus 7i/4, which much less cleaner than when you multiply, when you rationalize the two denominators, so two terms. Any question on this? Okay, then for the reducing, all you have to do is divide by 4. If the number is divisible by 4, your answer is 1. But when you try to divide by 4, it's not divisible by 4. The answer is -1 for even power. So for even power, you just straightly go ahead and divide by 4. But if you don't have even power, if you have odd power, then first you have to split into one power and the rest of the even power. So let me do this real quick. We have 34 even number, so just divide by 4. Then we have 30 is even number, so just divide by 4. 99 is not even, so you have to split 98 and 1, and then you divide by 4. 85 is not even, so you split into 84 and 1, and then you divide by 4. Now this 1 is actually I. Okay. So the first one is positive, this is negative, this is positive, and this is negative. So can you divide 34 by 4? Is it divisible? Can you divide 34 by 4 evenly? You cannot. So this answer is -1 because you could not divide by 4. Can you divide 30 by 4 evenly? We cannot. So this answer is -1. Can you divide 98 by 4 evenly? 98 by 4. 4 goes to 9 twice. We get 8. 1 is subtracted, you get 1. You get 18. 4 doesn't go to 18 evenly. Or never mind, 4 times 4 is 16. You get remainder 2. So this is not divisible by 4. So this answer is -1. And then lastly, 84 divided by 4, it's divisible. It's 21. So from here, the answer is +1. So what do you get? The coefficients for this one is 2. The coefficient for this one is 3. And the coefficient for this one is 4. So 1, 2, 3, 4, these are the coefficients. And you get -1 here. This is multiplication. -2 times -1 is +2. From here, we get -3i. And from here, we get -4i. So these two are like terms. These two are like terms. We get 1 minus 7i. And you must show your work. Whatever method you use, I want to see the work. So if you do everything mentally and just give me this answer and this answer, I'm telling you guys, I'm not going to give you any credit. I want to see the details work. How did you come up with these 2 lines? I want to see that. So if you remember in your in-class exam, I did not give points to many of you because you didn't show any work. Since in the final exam, I'm not gonna see you again. So if you don't show your work, then you don't get any credit. My Zoom says the session is expired, so I have to sign in. So most likely I'm going to get disconnected here. So if I get disconnected, then I'll meet you again, guys, on Thursday. And Thursday will be in-person class. Okay? So let me click on okay. I think we can stop here. So we did from chapter 3 to chapter 10. We went over all these. And with my other class, I'm going to go over chapter 11, 12, and 13. And then in our next class, so all of these are finalizing questions. In our next class, we are going to do another final exam. Okay? And
Miss, sorry, if you're in a rush to go to another meeting or something, or can I ask a question that I had because I'm a bit confused about B. I mean, I don't know how to say it. It's
which B you're talking about?
5i parentheses over 4i. Because I just want to know why we just changed. Yes, that one. I want to know why -4 still was retained, but a -4 for 7i was not. I was just wondering if there was a function or
So
something
we
that,
have +7 divided by -4. You mean this part, right?
yes.
So +7 divided by -4, positive and negative turns into negative. So instead of writing this way, this looks weird. We don't put double sign in one number. So you always combine the sign. When you combine plus divided by minus, it turns into a minus sign. So you
I
put a
thought we're,
minus sign here.
sorry, I just thought we were gonna divide them, right? Because I know like usually like if you have 7i plus 5 and you have -4 underneath it, you split the fractions, and I just thought, well, we split the fractions, it's done by. I'm just wondering why 5 isn't being times by -4? Is it because we're only interested in the imaginary number, or
No, because we are not multiplying, we are dividing them. So we have
what?
7i plus 5 on the numerator. So first thing I did was switch the position. The 5 should be written first and then 7i should be written later. So switch the position because this is the rule. The real number comes first and then the imaginary number. And they both have 4 on the denominator. And then
Oh,
we just split the denominator.
so is it because we're expressing this in a plus bi form? That because
Exactly.
that because 5 is in its normal place, but like bi is a bit different in the
Mhm.
sense that that we moved bi from the a place to the second.
It should be written first means the real number. So here our real number is written later and I is written first. So you have to move them around so that A is first and then the I number.
Yeah, that's what I'm saying, because we move A to be in the correct spot, and because we're trying to follow the A plus B BI format. I know it's not, I know that because it says A plus BI form, that doesn't necessarily mean that A has to be plus by BI as shown here, right? I was
But
just,
you cannot add A and BI because they are not two same number. A is a real number and BI is a BI is imaginary number. So you cannot combine them. You cannot add 5 plus 7i. So they are not combined, they are not like terms. Just like 5 plus 7x. You cannot combine them because they are not same number. They're not, what do you call it? They're not like terms. So that's why keep your 5 and 7i. The only thing you can do is split the denominator. That's the only thing we can do. But you cannot combine them.
okay.
So 5 plus 7i, they're not combinable. So you keep both of them 5 and 7i. And then you split the denominator twice. One is below 5 and one is below 7i. So when you put -4 below 5, you get 5 over -4. And you cannot combine them because 5 is not divisible by 4. So you have to leave as a fraction. 5 over -4.
Oh,
And
but since we already agreed that 7i is not a real number at all in the first place, it's an imaginary number, we're just trying to have things correct.
mm-hmm.
Okay. Oh, okay. I get it. Okay, I get it.
The -5 over 4 is our A, and then this is minus BI, where our B is 7 over 4. So I skipped many questions in these sections because we don't have enough time. But I'll look at another final exam for next class, and then we're going to go over that. So every questions I went over today, they came in the final exam previously. So I'm going to post this not the solution one, but the one we did before. Uh, come on. This one. I'm going to the combination of exam 1, 2, 3 review sheet. I'm going to post that again on Brightspace tonight and then study all these questions. We went over most of them during our lectures, and on YouTube, all lectures are arranged by their section number. So just look for the question in their proper section to see the solution. For example, if you're
Wait,
looking for,
Professor, I have a question.
go ahead.
I'm kind of locked out of the classroom when I have my stuff in there. Can you ask if there's someone in there?
Go to the next classroom and then ask the instructor to open the door for you.
The
Oh,
what?
wait, are you the one knocking in this room?
Yes, I am.
Oh, sorry, I'll open it for you right now. Hold on.
All right. Thank you, though, Professor.
So you went outside of the classroom and then they are not opening the door for you.
It's like another teacher. Okay.
Thank you, Elena. Thank you.
Thank you.
I have another question in a sense, so if you have enough time.
Go ahead.
So for question, it's before section 10.5, and it's question 5, multiply and simplify the following. And I believe the one you picked was option B.
Which section is it?
It's 10.4, I believe.
There is no 10.4, it's 10.5. You mean this one, right? Rationalize the denominator.
No, it's before rationalize the denominator and simplify.
Okay. This
That
one.
one.
Okay. So which one? 3, 4, or 5?
You picked option B.
Mm-hmm.
Right, and I was just a bit confused because I think I saw 2 different answers for that one, and I was like, okay, because you boxed in the original one, which was parentheses x plus y parentheses, and then parentheses again x minus y parentheses equals x
Oh,
2 minus.
yeah, I said these are conjugates. So anytime you multiply to conjugates, you get x squared minus y squared. So this is not a question. This is the background knowledge. Anytime you multiply to conjugate, the answer is the difference of their perfect squares.
Oh, so it's the formula, right?
Yes.
Oh, are you saying that all of these follow the same formula in a sense, or is only B the conjugate?
Only for conjugate. When you multiply any conjugates, any pair of conjugates, the answer is the bases. You take both bases, square them, and then subtract them. So
Okay.
we had conjugates here on 5E. This is a pair of conjugate. So we used this to multiply. You don't have to use that, but if you do use conjugates, the difference of perfect square, your life becomes easier.
No, because I was copying down the answers before, right? And like the answer you got right was, hold up, this is for B. I think the answer was 3x to the power of 5 times 3 to the radical of 2x, right? And I'm like, I saw your math and I saw how you did it, right? I was just wondering why 2 and x are being combined, even with radical. Sorry.
This is the question we did. Cube root of 3x to the 7 times cube root of 18x to the 9. Okay. So this is a different question. The answer for this one is what you said here.
Oh, those are not the same?
No.
Oh, okay. No, okay, never mind. Because I thought those 2 were the same question, and I'm like, you gave us. Okay.
So here, look at here, our B is this question. And the answer is this. On the left page here, what I did was I talked about conjugate here because I was talking about D. D is a conjugate problem. So I showed that just use conjugate here. Sorry, not D. What I'm doing today. E. E is a conjugate problem. So to talk about E, I said use the conjugate rule. And then your life will be easier. It is.
No, but isn't B though in the same problem? You solve for B. You solve for B and you also solve for D technically as well, right?
Right.
When you're using the formula for conjugates.
I did V, and this V is here on the right side.
Yeah, no, that's what I'm saying. They're the same, right? Because you're saying, right? That if a radical doesn't have like the same base in a sense, you can't really add them. So I was like a bit confused because like, isn't radical 2 and radical x not the same, or are they the same base?
They are not same.
That's why I was confused
So
about how.
what? So you're talking about the right side, right? So we have cube root of 2 and cube root of x. The reason why we combine them together is because they both have the same radical, cube root. When you have the same radical, cube root of 2 and cube root of x, as long as the radicals are same, then you're allowed to put them together under one radical. So you do cube root, one big cube root, and then you put every materials you have under the radical under one radical. So you may have multiple same radical, but when you're multiplying, you're allowed to put every radicand inside your one big radical.
Hold on, let me take a picture.
Mm-hmm.
Okay.
If you don't have the same radical and you're multiplying, then we cannot put them together. But here we have the same radical, cube root. So for the same radical, we keep our cube root once, and then we put all the radicands inside one radical. We are allowed to do that in multiplication and division. But when we add or subtract, we cannot do that. Okay. Any other question?
No, none for me.
So do any of you have any other question? No question from anyone? Okay, that's all for today. In our next class, we are going to do another review, okay? Next class will be in person. So make sure you start studying for the final. Our final exam is next week, exactly 1 week from today. So you don't have much time to prepare for the final. So make sure you use every second wisely. Okay? Say goodbye, guys. See you on Thursday.
Promise.
Bye, Elena.
Okay.